Hi everyone, here's a quick video going over some of the solutions and some hints and tricks for the solutions to the review packet. Okay, here's the solutions here. What I want you to note here is that I've put on here, let's go a little crayon today, how's that? Feel free to use PySimult or the intersect button on your calculator. So we are okay if you do that. You do not have to solve them by hand. Some of them might be easier too. These ones here we set up are pretty challenging because they have fractions, or in this case, they have three different equations. So feel free to use your PySimul. Now, that being said, you have to get them into the right form in case of number two, because they're both not a standard form. Or say for number one, number three, you kind of decide what you want to do. Let's look at number one. Slope-intercept form, you might just have to change your window. Here, your y-intercept is 10, but if you can picture this graph, it's 10, but the slope is -1/2, so it should be showing up there. This one here is 3, it should be going up here, so you should be able to see it. It might be further out here, so you might need to change your x max. Because one thing about the intersect function, it will only tell you and show you where the graphs intersect if you can see it on your viewing window. And I'm trying to remember off the top of my head, my guess is if you do let me just go here. So standard is going to look something like this, and the lines will not intersect in your viewing window, so you'll just need to change your x max maybe to say 20. Number two, just be careful. This bottom one is not in standard form. In PySimul, it has to be in standard form. X's and Y's on the same side, and the constant or the number on the right side by itself. So you will have to move this over here. So this will be 4x minus 5y equals 52. Top one is already okay. It's got the x and y on the left, the number on the right side. So make sure you put this one in here. And again, with PySimul 2, most of you have PySimul 2. Some of you have PySimul 1, which is what I have on my calculator. You just put the coefficients in. So let me erase this here. The 4, -5. So you would put this in a 6, 7. This, I think, is the old PySimul with a kind of a line there, -38. This one is it's 4, -5, and 52. I'm not sure why it doesn't work. Okay. So I have the symbols there. Number 3, that is all set to put into PySimul. You can put in fractions. That's the beauty of using PySimul, so you don't have to do anything. Put in -1/3, you just put in -1 divided by 3, and when you hit enter or tab over, it's going to put -0.333. So it's going to look much better. I have no idea why this will not write 3s on here. -0. I put in a new battery. I thought it was the battery, but apparently it's not. Apparently the screen is not great. So it will go ahead and do that. It will put in 0.5 for this right here. So use the PySimul. Let that do all the work for you. You don't want to deal with any of those fractions. And number 4, you have 3 equations, 3 unknowns. So on your menu screen, you will have to put in 3 equations, 3 unknowns. Again, you will have to get it. So we have something like this: x, y, z, and then the number over here. So you will need to go ahead and change this first and the third. So you get the x, y, z's on the left, and then the constant on the right. And then they'll just give you, I think it's x1, x2, x3, but 3, 2, 5. All right, graphing these systems here. I'm going to go back to crayon here, why not? Okay, this one here, y is greater than -x. There's -x. It's a dashed line because it's not equal to. It's greater than, so it's going to be up here. If I go to the green, this is y is less than 2x minus 4. Here's your 2x minus 4. I'm sorry, it's greater than because switch signs. So right now, it is this section all in here. And then we'll graph the third one, see if that minimizes that. Okay, so now the third one, back to crayon. The blue, y is less than x plus 3. So it's here, so it's down here. So the only thing that has red, blue, and green is this triangle right in here. Okay, hope you're okay with that. I'll stick with blue here for number 6. Y is greater than the absolute value of X. That's your V. Okay. It's a dotted line. So all this is shaded in because it's greater than. Let me erase some of this right here. This part right here. Crayon, that's this here. We'll go to red here. X is less than 3, greater than -3. X equals the number is the vertical lines. So now it's this whole thing here, all the way up here. So inside that V, and then it's brown. So Y is between 0 and 4. So it's all down in here. And then clearly the overlapping section here is going to be this little home plate looking space right there. Okay. As far as that, it doesn't go any further left than -3. It doesn't go any further right than 3. Doesn't go below 0. Does not go above 4. And then it is above the absolute value. That's why we get that section in there. Okay, on to the back. Eventually. Okay, so with our word problems, our applications. Again here, I'll do a little highlightage. Okay, you do need to sign the equations. You can use your calculator to solve them. Okay, so you can go ahead and put into polysimult, or if you're going to do second calc value, excuse me. Sorry about that. Okay, so you do need to assign the variable. So on your test, if you do not set up two equations, you will not get full credit. Okay, so this one is slope-intercept form. That says mx plus b. So one car model costs $20,000 and costs an average of 10 cents a mile to maintain. Another car, if you buy it, 28 cents, and they estimate that it costs about 4 cents a mile to maintain. Okay, so this is your standard or slope-intercept form. As we mentioned, a clear starting amount. In this case, 20,000 for one, 28 for the other, and then a cost per mile. We use that word per. There's your rate. So those are rates, anything per mile, per day, per hour, per person, something like that. That is going to be your slope. Okay, so the cost of Model 1 is 0.10x plus 20,000. Model 2, 0.04 plus 28,000. Those here. Now, if you want to graph them, you can. You will certainly need to change your window because of the y-intercepts. If you want to put those into standard form, you can do that. You would just go ahead and move the x's to over here. So this would be negative 0.10 x plus y equals 20,000. I'm running out of space there. And then if you do the same thing with the blue one, negative 0.04 x plus y equals 28,000. Obviously, you'd put the 3 zeros. I just did because I ran out of space. Now you can use polysimult for that. Now that's not going to be hard to solve with polysimult. You don't care about the decimals. That's why you're using a calculator. But if you choose to do that, that's fine. You certainly would have to set it up in slope-intercept form first. Then you go ahead and solve this. That's what you get for your answers. Now, if a person expects to drive a car for 100,000 miles, you would just substitute that in for x, the 100,000. And for xc, which is a lower value, if you want to sketch a quick graph, like we did earlier, the green one here, I'll go back here, 10 cents a mile plus 20,000. I'll just start that there. And then the blue one is going to start higher, 28,000, but it's going to be flatter because the slope is less than that. So this is 28,000. This is what, 20 over here for the green? And I'll just use red here. This here is was it 133,000. So anything less than that, you want the green. You want what's going to be cheaper to you. So 100,000 would be somewhere around here. You would obviously want the green one here because that's going to cost you less. So you would want the $20,000 car. And if you're going to sketch a graph, that's all I want you to do. I did ask you before, if I asked you on a test, to label because that's important. I just want you to be good with the units. This is the number of miles because that's our x value. And this is our total cost that would cost you to buy and maintain the car. Okay, for number 8, running that relay race here, we have all these numbers here. I did not right there. 5,910 what meters, 18 minutes. And I'm not just going to put meters for minutes there. 300 meters per minute. So 300. Sorry, this is not writing very well. Meters per minute. And then what is it? 360. This is slightly different than some of the ones we've done. You have to just take that. I don't know what else to do here. It says 300 meters per minute there. And then X and Y is just the number of minutes that each one ran. I'll do that in green here. So X is the number of minutes, Y is the number of minutes, 18 is the number of minutes. There's your first equation. And then for the second one, 300 meters per minute times however much the first guy ran or girl ran. There's the time for that because this is meters. This is your total meters that they run. This is your total meters the second person run. 360 meters per minute times Y. And then that gives a total of 5,910 meters. And certainly put that into polysymbol. All right, number 9, two angles are supplementary. That means they add up to 180. Hopefully you remember that. X plus Y equals 180. And then the sum of the measure of the larger angle is 20 more than the others. What I would do, I think I mentioned this, whenever you see the word is, that's your equal sign. Take the expression to the left of that, which I will underline in yellow here, and make that into equation. The measure of the larger angle. It doesn't matter which is which, but let's just say X is smaller, Y is larger. It does not matter. I'll make that a Y. Okay, and then now we'll go ahead and take this expression over here in red, 20 more than 4 times the smaller angle. The smaller angle is X. I'll just write smaller here. So if the smaller angle is X, 20 more than 4 times that would be 4X, and then we're going to add 20 to that. 20 plus 4X is obviously the same as 4X plus 20. You can do substitution if you want. This one wouldn't be that bad there. Oh, I don't know why I'm doing that. I erased it actually. If you want to do that, that just becomes X plus 4X plus 20 equals 180. That might be easy enough for you just to solve like that. Instead of putting polysymbol, because if you put it in polysymbol, you need to move this over, or you need to move this over here and graph in slope-intercept form. I would probably use polysymbol, but you can obviously easily move this over and make it negative 4x. It's up to you. This certainly is a pretty easy one to solve. All right, so number 10 is very similar. Sum of two numbers is negative 11.9. This is one where certainly you probably want to use polysymbol. And then for the second equation, the sum of the twice the larger and the smaller is, so I've underlined this was in color, is 5.4. So that's the right side. Now turn the left side into expression. The sum, that just means add, of twice the larger. I think generally whatever I treat the x as smaller, y is bigger because x comes before y in the alphabet. The sum of twice the larger, that's 2y, and the smaller, which is just your x, equals 5.4. Now I put here or 2x plus y, it doesn't really matter. So just be careful. If you put this in a polysymbol, that you cannot put it in just like that. You have to have the x's and the y's in the correct order. So first one obviously would be x plus y equals negative 11.9. The second one would be x plus 2y equals 5.4. Okay, you just need to make sure you put them there. Because if you put it in here, you get the wrong answer. So I just have to switch the x and y, polysymbol, and you get those two answers. And I believe that's it. Okay, hopefully that helped and cleared up anything you're unsure of. If you have any questions, any concerns, or whatever, anything you're unsure of, please see me before the test on Friday and before 9 o'clock, before class starts. Okay, good luck. I'll talk to you later. I will be putting up, if it's not already up there, well, it's not because I'm going to put this up today, but I will be putting up a second review with solutions on there. You can check that as well. Okay, let me know. Thank you. Peace. Bye.